what this lesson is like. We are actually going to pause in solving equations and solving various types of equations. And we're going to do something called learn the prerequisites. So you're going to notice that today is 1.7 prerequisite. It's actually not lesson 1.7. It's the skills that you need to be able to solve 1.7. So when you do your homework over the weekend, you're going to find the homework is from the book in a page that we did a long time ago, page 16. That is correct. It's on purpose. We're going back to the prerequisites before we can really dive into 1.7. I like this lesson. Do you guys ever remember those things? I just remember like as a kid, there were these sheets and you'd have to like figure out the code in order to like encrypt the message. You guys remember those? Like the little like, like you'd have to figure out what represented A and what represented B, and then it would code the answer. This is kind of similar to that. We're going to learn how to write your answers. So you're going to be kind of coding what you already know so that you can use this notation to be able to represent your answers on Monday when we look at these types of really inequalities. Okay, so that's what we're looking at on Monday. We're going to be solving inequalities. Inequalities, if you remember from Algebra 1, are like those less thans or greater than symbols. You should already have some knowledge about these. So let's go ahead and think about what reminders or what pieces you probably have already learned. If you have a less than or a greater than symbol, do you guys remember if those represent open circles or closed circles on a graph? So if it doesn't have an equal bar, it represents open circles. Open circles on a graph. Okay, so with that said, we have to remember what represents closed circles. And that would be, again, if there's an equal bar below those symbols, that means that the number actually is a solution to the inequality, and we represent that visually with a closed circle on a graph. And when you're thinking about a graph, the graph is a number line. That's what the graphs are when we look at inequality graphs. And then a few other pieces that are important for you to note. If you have symbols that look like this, that point in that direction, we call that the greater than or equal to symbol. So I would just represent that this is greater. And then the other direction, I'd draw the other direction, like this or this, represents your less than or equal to. So let's go back to a review inequality that you probably worked with in Algebra 1. If you had something like x is less than or equal to 2, what this means is that all values of x are solutions as long as they're smaller than or equal to 2. You could not name them all. There are infinite. So you had to represent these solutions on a number line, on a graph. So you would draw your number line. Quick reminder of how the number line works. There's a 0, and then numbers to the right of 0 increase in value. Numbers to the left of 0 decrease in value in the negative direction. And no matter what number you start with, the lesser numbers go to the left, the larger numbers go to the right. So if I was graphing x is less than or equal to 2, based off of what we reviewed, would this be a closed circle or an open circle? Closed because of the equal bar. And then would we shade the numbers going to the left or to the right? To the left, because this is a less than symbol, so it means the numbers have to be smaller than 2. Now, if you're ever unsure, you can actually use that symbol as a pointer. It's actually pointing to which direction you should shade. So for example, if I'm looking at this as an arrowhead, and if I kind of like draw dash symbols, that arrow is pointing that it should shade in this direction. That always works as long as your variable is on the left. So if your variable is on the left, you can use that symbol to point to the direction that you should shade. So let's go ahead and write that just because that can be helpful for some. When x is on the left. The symbol points to the direction to shade. Okay, because it's been a while since we've seen these symbols, we're gonna just kind of practice with them a little bit today. And we're gonna use those symbols and see how can we represent our answers in interval notation. So this is the new coding we'll be learning. What is interval notation? It's a special shortcut way to express a set of numbers that are solutions, or you can have multiple solution sets for an inequality, an equation, or a graph. So in those blanks, go ahead and write the word solutions or solution sets. So to help us understand this notation, we're going to use what we currently know from Algebra 1 and then apply it to this notation. So you'll see it says express the following as an inequality. You want to start committing that to memory as those symbols. So express the following as an inequality, and then after filling out the key below, so this is the key below, we'll use it to represent these answers in interval notation. So let's start with this first graph. If we were representing this using an inequality, we would say that x has to be greater than, would I do a greater than or equal to symbol? Equal, how do you know it's equal? Nice, because it's a closed circle. So I'd say x has to be greater than or equal to the number 2, because it starts at 2. Okay, if I'm looking at the one next to it, I would say x has to be greater than, would I say greater than or equal to here? No, because it's an open circle. And what number does it have to be greater than? 4, good. This next solution represents really what we call a compound inequality. It means x has to satisfy 2 conditions. We would say x has to be less than -2 and greater than -4. Numbers that would make this fit would be like -3 or -3.5 or -3.6. Any of those values would make this inequality true. Okay, let's do 3 more and then we'll learn this new notation. So this here is also a compound inequality. We would say x has to be, would I say less than or equal to 2? Good, less than or equal to, because it's a closed circle this time. And x has to be greater than or equal to what value? -3. Awesome. Okay, turn to your partner and the person with the longer hair in the group. You share the longest hair. Share what you think this next one would be. Olivia, I don't know. Do you have longer hair or do I?
Mine's like past my shoulder a bit.
I think you're longer than mine's like right to the shoulder.
Okay. Okay, so it would be -3 is less than x.
Good.
And it would also have to be less than 2.
Nice. Well done. All right, guys, take a look. You should basically have the exact same answer as the one before it, with the exception of no equal bar, because these two are open circles. Okay, and the last thing we need to take a look at is this is also representing the solutions to a compound inequality, but this is an or situation. It means that x has to fit one condition or the other one. We couldn't say that it had to fit both. So I would say x has to be less than or equal to -3, or x has to be greater than or equal to what value? -1. Okay, that was inequality notation. Now I'm going to show you the key for interval notation. The first thing to note about interval notation is that you have to write the numbers with the smaller values on the left and the larger values on the right. The nice thing is that that's how we read, left to right. So you want to know smaller on left, larger on right. Then these are the symbols that you could use. Either parentheses, brackets, comma. This is called an infinity symbol, and you always put a parentheses around it. This is called a negative infinity symbol, and you put a parentheses around it, and this is a union. Now we're going to talk about what they mean. Mario. After the infinity, we'll talk about that. For right now, I just want you to see the symbols, then we'll talk about really like what they mean and how do we know to use them. So parentheses. Parentheses represent open circles on a number line. So go ahead and write in the word open. What this means is that the actual number is not part of the solution set. An example of when you would use this symbol is if you have something like x is greater than 2. The brackets, these are more straight edged. They represent closed circles on a number line. Closed circles mean that the number is part of the solution set. An example of when we would use this symbol is if you have something like x has to be greater than or equal to 2, meaning that 2 actually is a solution. Then the other symbols, you want to know what they mean. A comma represents that the solutions go from one value or one number to, so it basically means the word to another number. The infinity with the parentheses represents that the solutions go to infinity. Now, Algebra 2 is really the place, I think, where I find that we learn the infinity symbol first. So you might even want to practice drawing it. To draw it, the way I do it is I start in the top right corner, and then it's just a sideways 8. And then you do always put a parentheses around it, but I'll tell you why after we've done a few examples. The negative infinity symbol represents that solutions start from negative infinity. And you can practice writing this one. You would just draw your infinity symbol and put the negative sign in front of it. And then in this case, the parentheses always goes around the negative symbol. And then lastly, the U is a symbol that will join two sets. Okay, now we're going to see how do you use this key. So go back up to the example that we first did, x is greater than or equal to 2. And I'm going to ask you this. What is the smallest number that x could equal? 2. So we'll start with 2. And can x actually equal 2? Yeah, it's a closed circle. So what symbol do you think we're going to put around the 2? Let's see. Parentheses represents open circles. Brackets represent closed. So good. We'll put a bracket around the 2. And then where do the values go to? Infinity. They keep going past 5, 6, 7, 8, and on. So I'd say the numbers go from 2, comma, that means they go to infinity. And then you always put a parentheses around an infinity symbol. I'll tell you guys why really after we get to the 6th example. Yes. On to the second example. If I asked you what is the smallest number x could be, that's kind of a tricky question because it's hard to answer. You would say 3.99999999999 forever repeated. So instead, we don't start there. We say the values start at 4, but to show that it's not really a solution, we put a parentheses around the 4. The parentheses represent open circles, and it's telling the reader that the values start at 4, but not really. It can't actually equal 4. It starts with everything after 4. Oh, and I said that wrong. Is that what you're raising your hand about, Caroline? Because I said 3.99. That would be if it was less than 4. I meant to say 4.0000001. Thank you for clarifying that. Yeah, it would be everything after 4. So I want to show the reader that it can be everything after 4. And so I do that with a parentheses. And then I want to say, what's the largest value that it goes up to? What would we say here? Infinity. And then you always put a parentheses around your infinity symbol. The next one, it's a similar situation. X can't actually equal -4. It would be everything after -4. So to tell the reader that it can't actually be -4, I would start with -4, but what symbol would I put around it? Parentheses. Now, where does this solution set stop at? -2. Would I put a parentheses around that or a bracket? Parentheses, because it's an open circle. Okay, let's do 3 more. So if I look at the next one, what is the smallest value that x can start with here? -3, and would I put a bracket around it or a parentheses? Bracket. It means that -3 is a solution. And the values go up to, where do they stop? 2. Would I put a bracket around that or parentheses? Bracket, because it's a closed circle, meaning 2 is a solution. Okay, turn to your partner, the person with the shorter hair in the group. See if you can do the next one. So Olivia, this would go from -3 up to 2, but they would be parentheses because they're open circles.
Yep.
Sweet. All right, guys, take a look. Did you do parentheses, -3 to 2 parentheses?
Yeah, it stops.
Yeah.
It has a stop in it.
All right, last one. We need to talk about this one. This one keeps going this way. So what's the smallest value that x could actually be? -infinity, awesome. And then we put a parentheses around it. And where do the values go up to in that set? Well, in this set, -3, would I have a bracket or a parentheses around that? It's a bracket because at -3, you still have that closed circle. Now, I know you guys are kind of questioning, well, what about this gap right here? This gap means, hey, these numbers aren't solutions, so I'm going to join one set with another set. The way that I do that is I just write the union symbol. It means that it could be this set or the following set. Because that's where it starts off closed. Or if I looked at the inequality symbol, x has to be less than or equal to -3. So I have to say that x can go up to -3. 2 different numbers? Well, we're not done.
Oh.
So now I'm going to have to say, where does it start again? So what's the, yeah, we have 2 sets here. So we'd say it goes from -infinity to -3, or where does it start up again? -1, would I have a bracket or a parentheses around that? Bracket, and where does it go up to? Infinity. Now the reason, just to give you guys a context, a bracket means that the solution set is closed off at that value. Like that's where it stops. Parentheses represent open. That's why you always put a parentheses around an infinity, because infinity isn't considered a closed off situation. It keeps going forever and ever. So we just always use parentheses around infinity symbols to show that, hey, there's no real close off here. It keeps going. Okay, on to some practice. That's the code. That's what you need to know for today. So now let's see if we can just get better at using it. So looking at the bottom, it says graph each inequality on a number line and write the answers in interval notation. So looking at number 1, on a number line, we want to make sure that we know how the number line works. We'd have numbers like 0, 1, 2, 3, 4. And one thing I would ask is if you're creating a number line, make sure to show at least 3 values. So we have to show the beginning and the end. And then I want to see, do you know that the numbers go smaller to the left? Or you could put a 5 after the 4 to show that they go larger to the right. Would we put an open circle or a closed circle at the number 0? Open, good. Because it's a less than, or yeah, it doesn't have an equal bar. And then what would I put at the number 4? Closed circle, and x can be everything in between. Now let's write this in interval notation. What number would we start with? 0, and will we put a parentheses or a bracket around it? Parentheses, and then they go up to, where do they stop? 4, would I put a bracket or a parentheses around that? Bracket, nice. Okay, turn to your partner, see if you guys can finish numbers 2 through 6 together. So that goes to the back page if you have paper notes, and then we'll come back together and check your work. Let's have this time the person with the darker eye color. You share what to do. Olivia, what color are your eyes?
I just know them as brown. I don't know what shade.
Yeah, I don't know mine either. I'll start it.
Okay.
Okay, so
So
like same with you. Mine is brown, but I have no idea how. So x is less than 4. We would have numbers like 4, 3, and 5.
Mhm.
And we'd have an open circle at 4 and we'd shade to the left, which means that x could start at negative infinity and go up to 4 with a parentheses. Does that make sense?
Yep.
Okay. Can you do number 3?
Sure. Okay. So you would write a line, yep, and then you could put 3, 4, 5, and 6.
Nice.
Then you would do a shaded circle on 4 and an open circle on 6.
Good.
And then you would do a 4.
And you'd shade everything in between it, right?
Yeah, shade
Okay.
everything in between. And then you would do 4 with a bracket around it,
Nice.
and then 6 with a parenthesis.
Awesome. Okay. And then I'll do number 4. We would have a number line. We would have -1, and I would have number to the right of it like 0, to the left of it like -2. And then I would have a closed circle at -1 and shade to the right. And this would represent a bracket around -1 going up to infinity. All right. Do you want to do number 5?
Sure. You would have -2, -1, 0, and then you could have 1. And then be an open circle on -2 and an open circle on 0, which would then give you -2 parentheses and 0 parentheses.
Nice. You got this. Then number 6, we would have 2 situations. So we'd have 1, and then I want to show that like 0's to the left of 1, like 4's to the right of 3. And then I would have an open circle at 1,
Mhm.
shading to the left, and a closed circle at 3, shading to the right. And I would say x could start at negative infinity and go up to 1 with the parentheses. And then I want to join this with another set, which would be a bracket at 3 to infinity.
Awesome.
Sweet. All right, guys. How did we do? Did we get number 2, parentheses, negative infinity to 4, 3, bracket 4, comma 6 parentheses, 4, bracket -1, comma infinity, 5, parentheses, -2 to 0, both of those parentheses, and number 6, parentheses, negative infinity to 1 with a parentheses, union with bracket 3 to infinity with a parentheses. Yeah? Sure. Any questions on this? Okay, let's do a few more. Now let's see, can we go backwards? Can you be given interval notation and then graph the values on a number line and write as an inequality? So now you want to see, can you write it with those less than or greater than symbols? So let's start with number 7. Number 7, I would draw a number line. I would have values like 2, 3, 4, 5. I'd want to show at least one other number. Would we have a closed circle or an open circle at 2? Closed. How about at 5? Closed, and everything is in between. To write this in inequality notation, we would say x has to be less than or equal to 5 and greater than or equal to 2. Or you could read that left to right as 2 is less than or equal to x, which is less than or equal to 5.
Why do we know whether it's close or open again?
Because the bracket indicates a closed circle. Number 8, we would draw our number line. We would have values like 4, 5 would go to the right, 3 would go to the left because it's smaller. Would we have a closed circle or an open circle at 4? Closed, good, because of the bracket. Would we shade to the right or to the left? To the right, because that's positive infinity, good. And then in inequality notation, this would be read as x is greater than or equal to the value of 4. Number 9, we would draw our number line. we would have values like -3, showing that -4 is smaller, so it would be to the left. -2 is larger, so it would go to the right. Would we have a parentheses or a bracket around -3? I mean, what am I saying? Would we have an open circle or a closed circle at -3? Open, which represents parentheses. And then would we shade to the left or the right? Left, good. And then if I was writing this in inequality notation, I would say x is less than, would I have an equal bar? No, because it's an open circle, -3. All right, try these last 3 on your own. I'm going to walk around. If you have a question, please let me know.
Why did it need to be like this? The arrows are going down.
This is read as x is less than or equal to 0.
Mhm.
And like I see in your answers, you know how to shade it, but
Mhm.
numbers less than would be over here.
Okay.
So if you're writing them together, they have to face the same way.
Okay, so
If
would
you-
this be like that instead?
Yeah. All right, guys, if you could look up here when you're finished, see if you got the correct answers. And then the other thing I want to point you guys to is technically like number 11 or number 10, you could write this as an and compound inequality. You would say x has to be greater than or equal to 0 and x has to be less than 4. That's an equivalent way to write that statement. The other question that came out earlier today is students asked, can you switch around the values? And I wanted to make sure to be clear on this. You cannot switch around the values with interval notation because, like I said, they have to start from smallest to largest. So if you have them flipped around, it wouldn't be correct. But the inequalities, the less thans or greater thans, that can be flipped as long as the symbol represents the correct thing. Like you could have this in the way that I have it in red. You could have it the way that I have them in blue. Any of those would be correct. Any questions? Okay, the other thing I wanted to talk to you guys about next week, The quiz was originally supposed to be on Tuesday, but I'm pushing that to block day. If you are a freshman, most likely you'll be on the freshman field trip next week, Tuesday. With that said, this is a mainly sophomore and junior level class. So we will be still learning a lesson on Tuesday. So that will be recorded under the previous recorded lessons on the bulletin board. Also, that night's homework, Tuesday night's homework, I'm putting a practice quiz on the back so that you guys can try that and review before the actual quiz on block day. So if you're a freshman and you know you're not going to be here, make sure that you either watch the lesson or look at the completed notes and try the practice quiz so that you can come in ready on block day to take that quiz. Alyssa. Yes.